Today is all about passing by reference and passing by value.
Oh my god, you are so funny. If you want, I actually have a spare Raspberry Pi. It's in the bedroom. Did I do something wrong?
I'm afraid I haven't been totally honest with you.
You didn't invent Backbone.js, did you?
No, it's not that. I'm Sharp Man.
Oh, thank God, because you meet a guy and they invented Backbone.js, and then it's all like,
Product owner Gordon. Thank you for coming, Sharp Man. Why did you call me?
Anti-Pattern's up to his old tricks again. He's trying to improve the performance of the city's AWS servers by passing everything by reference.
You know that's not gonna work. Why don't you call the cops?
Every cop I got is down in the Hungarian district dealing with the notation riots. I need you to enter the parking garage on Georgia Avenue and put a stop to this. And one more thing. HR said that they need you to put in your goals for the third quarter.
Soon I will check in my code. The city's servers will run more efficiently using less memory. He'll be forced to recognize my genius. I might even get a promotion. And no one can stop me. Not even Sharp Man.
It's important to understand the pitfalls between passing by reference and passing by value so you can understand them and answer them accurately in an interview. Now, at the end of this video, you'll understand why the villain Anti-Pattern wasn't evil. He was just confused at how C# actually works. So what I'm going to do today is show you what's going on in the actual memory locations as we pass by reference and pass by value. And I'm going to use some props as well. Now, if you're following along at home, the code for this is on my GitHub or my website. And please like and subscribe. So let's start with the standard pass by value that you do all the time. Here, there's a method, add two numbers by value. We're passing in 1 and 2. We're going to pass into this method, add two numbers by value, which adds these two numbers. So when we actually pass by value, we make a copy of these two numbers. Now, I can mess around with number 1 and number 2 all day, and these two numbers up here never change. That's because we have a copy. Once we perform all the math, these two numbers go away, and .NET returns the value. Okay, let's see what this looks like in memory. So here I have 1, as you can see, 1 and 2 have values 1 and 2 in memory. And I'm going to pass 1 and 2 into add two numbers by value. Let's step into it. All right, now let's put a watch on number 1 and put a watch on number 2. As you can see, number 1 and number 2 are copies. I can even fiddle with the memory by changing number 1 to, I don't know, 6, and it doesn't affect the original value. Need more proof? All right, let me change number 1 to 5. When we actually run through this, and keep an eye on number 1. As we pass number 1, it turns into 5. But the original passed value doesn't change. Okay, so I probably have you on board with pass by value, but what if you want to pass something by reference? Well, in order to do that, we need to use the ref keyword. Now let's see what happens on paper. Now, when we decide to pass something by reference, something interesting happens. So I'm going to set up my memory locations here. When we pass something by reference using this ref keyword, we're not actually copying this memory. We're drawing a direct reference back to the actual memory locations. So when we make a change, number 1 plus number 2, and feed that into number 1, number 1 says, hey, go refer to this memory location and put the result in there. In this case, it's 3. Okay, so what does this look like in memory? Well, we've assigned underscore 1 to 1. We've assigned underscore 2 to 2. Let's actually step into add two numbers by reference. Okay, as you can see on the watch window, 1 and 2, that number 1 isn't actually number 1. Number 1 is actually referring to underscore 1. And when we return, 1 has changed. So if you use the ref keyword, you are telling .NET to refer to the original value. Now, there's two other things I want to teach you regarding pass by reference, in and out. So the in keyword is passed by reference, but it's passed by reference as read only. So when you pass it in, you can't actually assign it anything. Now the out keyword is essentially the opposite of the in keyword. The out keyword passes by reference as well, but you can't assign anything to it before you go into the method. Once you go into the method, you must assign something to it before you return. Now, you've probably seen the out keyword before. It's mainly used a lot when you're doing try parse because you need a way to return success or failure and you need a way to return the result. Now, don't get too wrapped up about the in and the out keyword. I'm just letting you know they exist in case it comes up in an interview. Now, this whole time we've been talking about really primitive types, integers. So do classes behave differently when they're passed? Well, kind of. So in order to talk about that, we have to talk about value types and reference types and where they like to live in memory. Okay, now we've all heard about the stack and the heap. Now the stack holds values like integers, floats, and even structures. It's about 1 megabyte in size and it's super fast, but it's sequential. So when you enter a method, you add items to the stack, and when you leave the method, you remove items from the stack. Now, the heap holds stuff like objects and strings, and it's also serviced by the garbage collector. It's a little bit slower than accessing the stack, and once you put an object in there, it might take a moment to find again. But for all practical purposes, heap size is unlimited. Now, when you're dealing with reference types like objects and strings, they can range in size from this little guy right here to a bigger object right here. So it might not be efficient to make a copy every time you pass to a different method. But the good news is that these objects are stored in a heap and a reference refers to that object. So instead of passing the whole object, what if we just create a second copy of that reference and pass that instead? So when we pass a reference type to a method, we are making a copy of the reference. Okay, now to illustrate this, let's say I have this telemetry class, and inside this telemetry class, I'm holding 3 longs, value 1, value 2, and an average. Now I'm going to take this telemetry class object. I'm going to give 1 a value of 2 and 2 a value of 4. I'm going to pass it into average telemetry class by value. And this method here is going to take 1 and 2. It's going to divide it by 2 and assign it to average. So let's see how this actually works on paper. When a reference type is created, our variable exists as a reference to that memory location on the heap. So when it's passed to a method, we actually create a copy of the reference. So now you have 2 items or 2 references pointing to the same object in memory. So let's look at the memory and see how it works. Now let's step through this thing. So we're creating a new instance of the telemetry class. As you can see down here, everything is 0. We're assigning a value to the 1 property. We're assigning a value to the 2 property. Let's step inside. We're going to go grab our 1 and 2 and take the average, which is 3, as you can see here, and we're going to return. Now here's what's kind of interesting. Once we return, you notice TC stays the same. We didn't actually assign it anything when we returned. So how did this happen? Well, we made a copy of that reference, and we started passing that reference and doing all the mathematics, and that reference just kept sending all that new data to the old memory location. So passing a reference type by value creates a copy of the reference. So what happens when you pass a reference type by reference? Well, now instead of making a copy of the reference, you're passing the actual reference. So you're getting a direct line to that memory location. Okay, so let's say I got 2 telemetry classes, TC1, which I fill up with 2 and 4, and TC2, which I fill up with 3 and 5. I'm going to send that to swap telemetry class by ref. Now, if I step into this, I want to show you what happens. All right. So we head in here and we assign TC1 to TC2. Now look down here at the actual memory locations and see what happens as soon as I make this transfer. So we told TC1 to go reference the memory location of TC2. Now the data in TC1 is poof, gone. We're never going to find that data again. So in order for this swap function to work the way you want it to work, you would have to create a temp telemetry class. That way you don't lose your place when you reassign the variable, and assign that temp class to TC2. So passing a reference type by reference really doesn't make anything more memory efficient. But I'm sure you can see how a villain like anti-pattern thought it might increase efficiency or decrease memory. Anti-pattern probably knew enough that passing by value makes a copy, but he probably thought whole objects were being copied, and as I've just shown, they aren't. So how does a myth like this get started? Well, a lot of it comes from structures. Remember how I said structures are on the stack and not the heap? It's actually more efficient to pass a structure by value as long as it's under 24 bytes, because then you're not adding to that stack as you copy more and more structures. Anything over 24 bytes, and it's just more efficient to create a class. Now, I do want to cover one more thing. If you have an array of structures, does the array of structures live on the stack or the heap? Is it more efficient to pass an array of structures by reference? So put a pin in this because it's probably going to be an interview question. Array inherits from system.object. So an array of structures lives on the heap, unboxed. An array of integers lives on the heap, unboxed. So passing an array by reference doesn't save you anything. So to wrap it all up, value types like integer, float, structure live on the stack and are copied and passed by value unless you declare otherwise using ref, in, or out. Reference types, like a class, live on the heap, and when you pass it into a method, a copy is made of the reference, unless you pass by ref and declare it otherwise. And while passing value types of a certain size, like structures, may result in some efficiencies, you don't get the same efficiencies out of classes that live on the heap. Good luck on your next interview.
I'm afraid it's too late, Sharp Man. I've already checked in. Soon Jenkins will take it through the pipeline to Elastic Beanstalk and the city will see my genius!
What have you done, anti-pattern?
What have I done? I've saved this city. Passing by reference will save thousands in AWS fees.
It doesn't work that way.
You know, you and I are a lot alike. We both want the same thing. We both want to make the customer happy. And look at you with your style guides and your standards. Programming's about getting the job done.
Maybe we are alike, but there's one key difference.
And what's that?
I remember to push my commits.
No! Ah!
Send message to stakeholder Gordon. Tell him I've got anti-pattern's performance improvement plan ready.